you will not go one by one execution because the script has already the resolution there. Is it clear?
Yes. Like after one time we can learn source then.
Yes.
Sir, I'm asking like if we can modify that script and directly source by calling that script file, can't we get our issue was solved?
Yeah. Let's say let me do it. So you are talking like I exit the tool, right?
Yes.
I call the tool decision. Then I load the design, source, script, one.pickle, one read design. So I will then I source the solution script that I just developed, right? Source the script. You see the ingredients you are taking not there. So you see, what is the JS? So it's already in, right? So in the next run, when we have already debugged all those things with the things that we have to put into our script, then in the next run we can directly run it. And it will run automatically one by one. But when you are doing debugging, you have to put manually command and say how the tool is interacting, whether it is able to solve or not, right? You have to make sure that the solution that you are talking about, it has to work properly into the tool interface. Otherwise, it will not make any sense. So once you are confident that the information is stable and it is working perfectly into the tool environment, then you put it into the script, make it a final revision, then you exit the tool and rerun the design. Everything will be in one block. Okay.
Okay, sir.
Okay, I think let's try to see what are the additional violations that we have. So this is one kind of modeling violation. So all this modeling violation is coming from the PLL and RAM. These are coming from RAM, ROM, and PLL. So as I already mentioned that PLL is an analog design, RAM, ROM, these are all analog design. So in your design, you will see this as a hard IP, not any Verilog or RTL coding. It's just a hard IP will be sitting there. So when you do the scan insertion, all those things, it will be like a black box to you. Because what is there inside, you are not taking care of it. Or you are not concerned about it. Because it's a hard IP, it will be just directly put into your design. That's why this is something called as a black box model. You see, unknown black box. Because the functionality of output pin clock is bad or incomplete. So it's not there. So we don't bother about it because we already know that this is something will automatically be there in the design. So nothing need to be worried about it. But if there is any other thing apart from this one, like functional, some other block apart from RAM, ROM, PLL, all those stuffs, maybe you forgot to put some of the design RTL file, then it will also be reflected as a modeling issue, black box. Then you have to analyze that and then add that particular design so that that black box can be go away. But right now, I think based on our design, it should be perfectly fine that we don't need to worry about these TRC rules. Okay, and I think for the topology, they are mentioning that these are the ROM pins. Actually, you see, all those things belongs to RAM and ROM. So the RAM and ROM input output, and also there are some other module is sitting here. But it's like all those things belongs to same concept, which they are calling as a improper driven tri-state net. The violation is the tri-state net. It is not being driven properly. So this is the pin tri-state net something is not driven properly. So if you try to look into that, I think the schematic will not give you that much information. Right now, it's just pointing to the pin name. that it is facing, that it's a tri-state things happening there. So from here, actually, we don't want to fix this kind of things. We will provide a feedback to the RTL team that these are some kind of tri-state net we are seeing, then how should we actually handle this? Before we fix anything, we must need to consult with the design team that what is the functionality or how they are actually going to handle it. And from the DFT perspective, how should we modify this? Ultimately, you can modify it at your own, but if it breaks your functionality, then everything will be mess. So we can provide a feedback to them that this is something we are observing at our end. Is there anything that they can do to fix it so that it can be more DFT friendly for us? They can put, like in clock path, they are already put the mux to control it through the test mode signal. Maybe this tri-state buffer net, all those things, they can also try to put a mux to control the enable net to make sure the buffer can be operated safely during the scan mode. So we can request them the feedback as well. So these are, I think, these are not the severe violation. So we can provide the feedback, but it's not something that will block you to go into the next stage. Meaning you have already been seen that you have already this number of flip-flop value itself. Now, if you put some kind of scan architecture like scan in port, scan out port, chain numbers, then you can go into the scan stitching of the flip-flop to build the chain. The tool will not block you to do that. But it's still okay that this violation is there, but it is not blocking you. Okay. So any other question? I think that's all that for this lab, Philip.
I have a question, sir.
Yes, please.
Can you open that constraint.tcl file? Constraint file.
This one?
The constraint file which is there.
Oh, constraint file. Okay, sure. Okay.
I think in this I encountered one set configuration command was there, scan configuration command was there. Yes, this set scan configuration. So why we are using it over here, I was not able to understand it.
Yeah, actually, it doesn't, I mean, those who are actually writing this script, they should not put it here. It's part of the scan configuration. So it should go into your toolcase.tk where we actually populated all those scan related information. So it doesn't have anything because, I mean, it's a default setting. By default, if you don't define any style, the tool will automatically pick up the max flip-flop style. But why they define it, it's not actually making any sense. But if we define it here, it also not breaking any other things for us. But it should be fine. We can remove it and take it into our two test protocol.detail there. And I think one of the things that even if we ignore this one, then it should not make any difference because the default style is the maxed flip-flop. So mentioning it explicitly doesn't make any difference. Okay. And another thing, maybe the thing is that because this constraint file will be exercised during the synthesis, right? When the tool do the synthesis, actually it will try to replace all those logic to some flip-flop, right? So with these things, maybe we are actually instructing the tool to use always the flip-flop to replace the memory logics. Otherwise, let's say it is actually using some kind of LSSD, latch, all those things. Then it will be problematic, right? So the tool actually needs some kind of guidance. Maybe the compile, because during the synthesis we use the command, right? Compile minus scan. So all those things actually direct the tool that you should always use the flip-flop to replace the memory logics rather than picking up any other kind of storage element. It is, I mean, we are actually instructing the tool in that way. Okay?
Okay, one more thing is there. Like, what would be the flow of our execution? Like, first of all, we'll be executing that compile file, and then we are going with the one root file, and
Yes.
after that, we'll be executing our main script.
Main script, yes, exactly.
Okay. So, can you open that one root file once?
One V, right?
Yes,
Okay, sure.
one root. Yes, in this, the upper first two commands are same as, similar to the ones which are defined in our compile. So what we are trying to do over here, I am not able to.
Using these two commands.
Yes, the first two commands, these are very much similar to the ones that we have in our compile script. I mean, the inputs are different maybe, but these are very much similar to them. So, how we are having this flow, I am trying to understand.
Let me 1 second.
Here we have this Presto, enable Presto for VHDL, and in that another type of.
Which line number you were talking about? Line number?
The 6, 7, and 8.
HL in enable Presto for Intel true. Okay, SCS, so this RTL path that we should look into that. And what's the thing to represent? Actually, these are some settings. The baseline settings. I'm not sure exactly what it is actually doing, but maybe one thing we can do is that if we just comment out these two and see what is the change in our analysis. Is it actually making any difference in terms of DFT analysis? That's the best way that we can figure out that what is the importance of this one. Let's say now we have done all one, so we have a reference log file. So if you just disable these two and run it and see if the log file is still same or not, or is it making some difference, then the tool will tell you that some issue it is finding. From there, actually, you can backtrack and put it away. So this is one kind of things that debug things. If you want to know, is any of the script, like usually the script is developed by someone else, we use it and we only concern about what is we need to change or update. That one we properly understand or not. But the remaining thing that is actually putting, maybe that is some design optimization settings, some other stuffs, all those things. If you want to do some understanding that what is actually impact of these settings in the design, then you can remove it and try to rerun and see what is the difference into the log file. From there you can understand it. Another thing is that you can directly look into the guide to see what is the information actually it means. But what for my suggestion is that before going to the user guide is may not be that much helpful because it's a generic information. But if you can execute and see the difference, then you will understand what is the importance of this. But right now, I think I don't have any proper understanding, but it looks like these are some settings to do some kind of settings.
Yeah, yesterday I did feedback this same design or even this system made by environment. So maybe we are related to that only.
No, this part is okay. I mean, this part is actually doing the design load really perfect. This is just some generic settings which I don't know exactly what is doing it, but this is we have to do it because we want to load the DDC is the gate list, gate level net list that we have done through the compile.data. So you see our flow. Our flow is done from some synthesis using the RTL code. That is what we are doing into the compile.data. The compile.data we are not doing any expansion and all those stuff. We are just simply using this script to synthesize this Verilog code into a gate level net list. What is our output? That is the output, right? Right. This is the output of a gate level net list with a lot of constraint and other optimization steps. But once we get the net list, we are okay to kick off our scan activity. So we first read the design by read this command. So in your tool, when you work into the tool, it can accept netlist and start to work from there. So this is the flow here. We are reading the netlist and we started to work. After we read the design, then we apply our test protocol, all those DFT related settings, and then we check our DSC. So that's the flow actually. Is this that you are asking, or I'm still not able to answer properly?
No, it's fine. I mean, I've been able to understand. One last thing is, I mean, in the earlier lab that we do, there was this .spf file which was there that we were writing. But in this lab, we are not writing that out. So is it fine? I mean, if we are not doing that .spf?
No, I think you can write it out. You
Okay.
can write the .spf also. After you DFT DSC check, you can use that command write test protocol, and you can write it out. But in this lab, actually, it didn't included that. But definitely, you can write it out. That is our output for this particular design.
Okay. Actually, when I was trying to do the analysis, I write that thing out in this here in this where it is written write out the test protocol. So it was giving previous errors. It was giving like that.
Is it okay? Let me quickly check. I go to my previous lab 2 on protocol, and see what was the exactly command. So write test protocol, right?
Yes. And this command is there in the solutions script that we have for lab 2B. So that I tried to write in the tickle file.
Okay, but if you try to write it, okay, let me just do this. But it's a folder, it should be. Cannot open file. Oh, the folder doesn't exist actually. We have to create this folder.
ORCA, I think. Instead of this for it would be ORCA.
Okay, yeah, I think I'm just trying to write it, but just think if I can write it or not. ORCA. It has been written out. So, did you get any error on this one or what? Sorry, I didn't.
Yes. Actually, when I was writing that thing, I mean the write. So it was saying that write command is not recognized. So maybe due to the earlier violations that we have, maybe due to that I was getting them. Or I have done some. I mean, out of steps I have gone maybe.
Okay. Write this protocol. Maybe. Or did you manually write it, or you write using the tab to take the actual command? Maybe it's some alphabetical mistake, all those, it can happen. But the command is available.
Yeah, it was there in the dot solutions file, which is there in this lab. From there, I copied it and I tried to. So at that time, it was saying this write command is not recognized.
Oh, okay. But I think you can try again. But maybe maybe I can check for you again. See, I think not sure whether I have already error -a. CD solutions. Achievement. Right, this protocol is already there. Okay, let me try to copy and paste it. See, maybe this switch has some kind of issue here. SPF. It has been written out.
Yeah, okay. On my side, there is something wrong question.
Okay.
Thank you.
Okay, no problem. Yeah. Okay, I think that is all that is for this lab. I think we have learned a lot of things because we encountered the issue. Now we discuss the resolution, how to do that sticker. So it's a good thing to encounter the issue, but at the same time, because it creates a lot of way to think of it out of your box. Everything, if it is automated, then there is nothing to learn. So maybe you can start practicing this lab by following. I think you can go to my script or my folder where actually this file contains the solution. Is to create this protocol underscore original, this one, in my script solution and see how it works. Okay?
Okay, that's one thing I have to ask.
Yeah,
So
sure.
the option of Autofix actually means the tool provides that if we enable that, so it will fix the whatever violations are there. So anyway, it is the right to do means you need to analyze and just debug that thing. But
Yeah.
it's Autofix. We are doing that. Just wanted.
Do you remember what is the exact command to enable the autofix?
That I don't know, because of that I'm asking.
Okay. Yeah, actually, if you look into the command reference, I'm not sure if you look into the DFG DRC, C minus help. Actually, I was also thinking to apply the autofix. I mean, just to give it a try, but I don't see that option is here. In Synopsys tool, really, they have another tool they call as a Fusion compiler. The Fusion compiler is an integrated version of scan tool or physical